Alright, part 2 of the 12-2 homework. Sorry about that last one in the audio. I didn't have the mic plugged in. That was just me being stupid. Okay, here we go. This should sound better. I'm supposed to find OM, OA, and BC. I just copy-pasted the same graphic from the last one. Right triangle right here, VOM. Hypotenuse is 5, so that's going to make OM 3. By seeing enough of these problems lately, you should see that OM is going to be half of OA, so it makes OA 6. I did one of those not so long ago. If you're looking at the base here, A, B, C, here's the foot of that height, and this exactly in the sort of center. This thing, that would be the same as that. This is double. I put 2 tick marks. That doesn't mean that's always, but I'm just saying that one's double of this one. So, and that's the same as this. So if this is 3, this has to be double of 3. So this has to be 6. This is the same as the size on the last one, actually. And B to C, you know what? I could actually look at that. I already knew that this one was 3 and this whole thing was 9. So this side right here would be M to C. Oh, we want B to C. Would be 6 square root 3. But I could have figured that out on this one on its own. If I know this is 3, I know this is 6 in this little right triangle, yeah, 30, 60, 90. This has to be 3 square root 3. So the whole thing is 6 square root 3. There we go. Okay. All right, slightly different version, same problem. The height is 3. This edge over here is 5. I'm supposed to find the slant height, the lateral area, and the volume. If this edge is 5, I guess they're really all 5. There's a right triangle with this 3 and this 5 in it. If you go across from like O to C, that has to be 4 in a 3, 4, 5 Pythagorean triple. That, if you're looking at the base of the triangle now, that's the distance from O to C. If that's 4, that'd be like this would have to be 4. This little thing would have to be 2 again. Remember, this has to be half of that. In this little triangle, actually, because here you go 4 and 2, there's your 30, 60, 90. This would have to be 2 square root 3, so the side of the triangle is 4 square root 3. The area of this base, you know what, as long as I'm at it, I'm going to need area base for volume. I could say this right now, this would be half, is way out of order, I guess. Half times base, and we mean base of the triangle, times the height of the triangle. This is 12 square root 3. That would be nice to know for B. I'm going to need to know that later. Anyway, what else do I need? What am I trying to find here? Trying to find L. Okay. This little thing is 2. I have a right triangle with 3 and 2 and L. 3 squared, this is not a nice one. 3 squared plus 2 squared equals L squared. 3 squared is 9. 2 squared is 4, so that's that. L is the square root of 13. Not pretty, okay. This is a half times P times L, and that is, P is perimeter of the base. Well, I know each side is 4 square root 3, so that's 12 square root 3 times L I just found. Just give myself some more room here. Nice. Half times 12 is 6. 3 times 13 is 39. So that's what we have there. I guess I need that much room. And 39 doesn't reduce, I don't think. Oh, three factors of 3, 13, of course it will. And volume is 1/3, because we're talking about a pyramid. Base times height. I have my base area of 12 square root 3. Oh, interesting. The base area is the same as the base perimeter. That doesn't happen very often. And times the height of 3. So this is 6 times 3 is 18 square root 3. And there we go. I don't know about you, but I'm just about sick of this little pyramid. Okay, so new problem 25. The lateral edges are 10. The base edges are 12. I think it's going to be easy to find slant height. I'm supposed to find lateral area and volume. For this, I need slant height. For this, I need area of the base and height. So I kind of need everything I've always needed. P is not too bad. I have that already. L, I'm stuck. Let's look at a face, like a side face here. It's an isosceles triangle. I know this is 10. I know this is 12. So to find slant height, I know this is 6. That's nice. Pythagorean theorem tells me that's 8. All right, so half times 36 times 8. I actually can't do that in my head. That would be like 18 times 8, which is 144. I probably should have been able to do that in my head, but I couldn't. Sorry. 1/3 area of the base times height. Well, I don't really have any of those things right now. The base looks like this. I have a 12 there. This would then be 6. This is 6 square root 3. So the area of the base is half times base times height, which is 36 square root 3. Okay, so 36 square root 3. times the height. Okay, the height I still don't know. Slant height was 8. This little thing in here is going to be 1/3 of the height of the triangle. We keep talking about how this is half of this, so if you divide this into 3 parts, you'll get the piece you need down here. So it's 2 square root 3. So to find the height, I have a hanging rectangle in the middle. That's 2 square root 3 on the bottom. And the slant height is 8, and it's in a right triangle with the height. So h squared plus 2 square root 3 squared equals 8 squared. That's 64. That's not bad. 2 squared times square root of 3 squared, that's 4 times 3, that's 12. H squared is then 52. I think that comes out kind of nicely. I can pull a 2 out of that. 4 times 13 is, yeah, 2 square root of 13. And yeah, this is 12 times 2 is 24. 3 times 13. Oh, we just had another square root of 39. Interesting. And there's your volume. Alright, I'm supposed to find the volume of this pyramid, and I have this thing in here. I'm supposed to get tricky with it. Alright, area of the base times the height. Well, I think the height's going to be the problem. Area of the base isn't too bad. Area of the base, this is a hexagon, which is going to be regular polygon. These are 4. So the little sides here are 2 and 2. This little apothem then is going to be 2 square root 3, because I have a 30, 60, 90 like that. Alright, so that's the apothem. Area of this thing is half times the apothem. It's half AP. Half times apothem times perimeter. Perimeter is 6 times 4. So the area, this is the all area base. This isn't too bad in the grand scheme of things. This is 24 square root 3. And like I said, I think the hard part is going to be the height. Height, okay, yeah, I have a little bit of a problem here. I know that this is 4. Like this one I just drew here, that's 4. And I know a 50-degree angle. I need to find if this is 50 degrees and this is 4. I need to know this. This is opposite and adjacent with this angle, so it's the tangent that I want to talk about. Tangent of 50 is opposite over adjacent. So 4 times the tangent of 50 is going to equal h. And for that, I must have a calculator. 4 tan. Oh, you know what? I don't even know if this thing's in degrees. It's not. That's how you know you're not in degrees. Look at that. There we go. That happened to someone the other day. Yeah, let's do that again. 4 tan 50. It's more like, yes, 4.478. Gosh, this thing can't make h's today. 4.78. And then I multiply that by, you know what? I'm sure we're going to want, it says nearest cubic unit. Well, we can do better than that. This is times 8 square root of 3. Let's go back to this and just leave that there and go times 8 square roots of 3. And we get that. 66 point, well, it's really close to 66. 66.05. This is actually approximately equal at this point. They say 66 in the book, so that's okay. 28 is interesting. It's about ratios of volumes, and they don't give you kind of what you would need. They have different heights, so let's call this H1 and H2, the heights of these things. H1, H2. We'll figure out what they are when we need to. But the volume of this one is going to be 1/3 times 100 times H1, and this one is going to be 1/3 times 100 times H2. So their ratios are actually H1 to H2. So I just need to figure out what the ratio of their heights is. Let me tell you that the first one, there's an angle, sort of an edge height. You would draw the height in here, H1, and there's a 40-degree angle down here. I should change colors. There's a 40-degree angle with this segment here. Now that segment is actually from the center. It's like the radius of the square. It's like from the center to that corner. If this is and it's the same on this one. So we're talking about the same ones here. It's just now this is an 80-degree H2, and this thing is even the same. So yeah, it's that same weird like radius back there. That radius would have a length of, looking at the floor of that pyramid, it's like we're talking about that segment. This is 10. This has to be, look here, we have a 45, 45, 90. This has to be 5 square root 2. So this thing is, and this is also 5 square root 2. You know, I don't even know if I need to know that, because watch. Here, this h1 is tangent. It's just like this. Tangent of, it's really close. Tangent of 40 times, so not 40, yeah, 40. Tangent of 40 times this weird 5 squared 2. This is 5 squared 2 times the tangent of 80. Well, we're finding ratios here. If I take 5 squared 2 tan 40 over 5 squared 2 tan 80, the 5 squared 2's are going to cancel, and all I really care about then is the ratio of tan 40 to tan 80. That's kind of a cool little problem. That's the ratio of areas. I could actually figure out the areas, or sorry, ratio of volumes. If I cared about the volume, I could actually find it, because I can actually get a number for this, and I can get a number for that, and I know the area of the base already. Really, this is H1, this is H2. I could just find those if I had to. Okay, I'm actually on to the 12-3 questions now. This is number 12 on page 493. We're here now. All right, it gave me the height and the... This is a really bad drawing. That's 2, that's 6. We're supposed to find all these other things about this cone. Radius here is in a right triangle with the 2 and the 6, so 2 squared plus r squared equals 36. So 36 minus 4 is r squared. So r is the square root of 32. And this pulls apart pretty nicely, because I can get a 16 to come out of there as a 4. It's 4 square root 2. Okay, radius is 4 square root 2. That's nice, because now I have all the ingredients I need for all this stuff. Lateral area is a half times p times L. And in circle land, p means circumference, 2 pi r, times L they gave me. So that's just, oh, I should be able to fit this in one column, because then I can do other problems on the same page. Running out of digital pages. I don't know why that bothers me. Okay, so this is 24 pi square root of 2. This is lateral area plus base, which is 24 pi square root of 2. I said square root of 2. Times, or sorry, plus pi r squared. And r is 4 square root of 2. R squared should be 32, right? So we have 24 pi square root of 2 plus 32 pi. I don't really want to add that up anymore. I could factor out an 8 pi or something fancy, but I'm not going to do that. Volume is 1/3 times the area of the base times the height, which here is 32 pi times 2. Oh, these thirds aren't going to go away. It's just 64 pi over 3. Yucky numbers. Okay. Okay, in this one, they gave us a lateral area, and you want to find all this other stuff. All right, so radius is going to be involved in this. This has to equal half PL. And they gave us the L, so that's good. First of all, I know that P had to be 2 pi r, and L, they told me, is 15. If that equals 180 pi, then great. I know the pi's cancel, the half and the 2 cancel each other right there. I have 180 divided by 15. Whoops. 180 divided by 15 is r. What happened to what? I don't want that. Straight clicks. And that turned off. 180 divided by 15. That's 12. Great. R is 12. Need to know that. Oh, look, I have a 3, 4, 5 thing. This has to be then in a Pythagorean triangle. Divide by 5. No, divide by 3. Divide by 3. That's the 4. This would have to be 9. You've seen a lot of 9, 12, 15s in your Pythagorean experience by now. Total area is lateral area plus base, which is 180 pi plus pi r squared. That's 144. 144 and 180 is going to be 324 pi. And volume is 1/3. I got about 30 seconds. 1/3 area of the base times the height, which is 1/3 times pi. Area of the base is 144 pi times 9 times a third. That's 432 pi. All right, that's it for this video. I'll see you in a minute in the other one.